Okay, today students, we are going to be reviewing transformations. It's a topic that we learned back in middle school, but we're going to just bring it up a notch to the high school level. So our learning objective today is transformations. A transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. The new figure is called the image. A transformation can be shown using an arrow. Now this is the part right here. This right here is what makes it the high school level, because you probably haven't seen this transformation notation before. That's what this is called, transformation notation. And how we read it is P prime, which is this right here, P prime, is the image of P. P is the original polygon that we drew, then we changed it somehow, and so this is the transformed polygon, or the image. Okay, next one, a congruent transformation, or isometric transformation, changes the position of the figure without changing its size or shape. There are three different types of congruent transformation. The first one is called a translation. And your teachers before may have told you, whenever you think of translation, look for the SL, and it should remind you of a slide. It's where we slide the shape from one location to the next. Slide. Moves every point of a figure the same direction, or the same distance in the same direction. Okay, next we have a reflection. And some people think of it as flip because of the FL. Some people think of reflection as a mirror, like a mirror image. Alright, the next one, rotation. Okay, so rotation, make sure that looks like an O. Rotation is where we turn the figure about a fixed point. And the fixed point is called the center of rotation. And this is a turn. Okay, so now let's go through a few of these examples here. And the first one, see it'll talk about it up here. Here's our legend. This unshaded triangle is going to be our original polygon. The shaded in triangle is going to be representing our image, or our transformed polygon. Okay, so here, what type of transformation do you see? If you look, it is sliding over to the right, so it is a translation. And the distance that it slides to the right becomes the rule. Alright, so here, let's say that this point, from this point, it's sliding a distance. Distance A, we don't know because there's not any tick marks here so we can count how far it's moving. So we're just going to say it's going to go from here to here is that number A. Alright, so here we start off with X, Y is our first coordinate, and how is it changing? And remember, that's what makes it transformations in high school, is because we're using this transformation notation. How is the original point changing? Well, though it's not moving up or down, it's just moving left or right. So that means that our X is going to change by this amount right here, by A. So we're going to add A. But Y is going to stay the same. If you look at this one's the same thing, except for it's just moving down. So it is a translation. Okay, and So we start off here with x and y. How is it being transformed? Well, remember, it's not shifting left or right, so there is no change to the x. But because this is being moved down, we're shifting it down. How is it moving from this point to this point? And we can choose any of the corresponding points. But I'm going to say that the distance between here and here is b. And remember, because it's being shifted down, that b is a negative number. So y, that would be y minus b, because that means going down. If we were to say up, shifting up, that would be plus b. Okay, and the next one, we're moving over to the right, and then we're shifting down. So we're making two transformations. This is a translation, and we're making two moves. We're changing the x and the y. So the rule here, we are going this direction, A, and then we're going this direction, B. So this direction is the change to the x. So that's going to be x plus A, and this direction is the change to the y. So that's going to be y minus B. All right, let's just review, and I'm going to put those extra notes over here in the margin, or over here in the margin. Alright, so here for transformations, I'm just going to rotate the paper around. If I slide to the right, that means I'm going to add to the x. That's going to be x plus the number, however many times we moved. If we slide to the left, that means that's a negative distance that we're moving, so that we're going to subtract the number of times that we moved it. If we slide up, that means that we're going to take y and add some number to it. If we slide down, that means that the y is what's changing, and so we would subtract that number. Okay. Alright, in the next section, you'll see that they don't look the same. So it's not just sliding it over. This right here is what we call a reflection, because it's been flipped over. And this right here is a reflection across this axis. So if we fold this piece of paper right here along this axis, it will map onto the other polygon. So this one will map onto this one. So this is a reflection across the y-axis. Okay, so the rule for this one, x comma y, we have to figure out what's changing. The easiest way is just to put some fake tick marks here. I'm just going to say this is going to be 1, 2, 3, so we're estimating. So we're going to do 1, 2, 3. And let's try to name this point. 1, 2, 3, 4. Okay, so if I was to name this point, it would be negative 3, comma 4. And if I was to name this point, that would be positive 3, comma 4. Now look at the difference between the 2 points. The x's are different, but the y's are the same. So here the x's, because it's being reflected over the y-axis, only the x's are going to change. One's going to be negative, one's going to be positive. So here what we do is we say negative x comma y. The x is the only one that changes. Alright, here's the next one. This one is going to be a reflection across the x-axis. Remember, this one's the x, this one's the y, and of course that was the x, that's the y. Alright, so on this one, it's going to be the opposite of this one. Start here with our x and our y. And how is it changing? Well, the only thing that's going to change is our y, because it's going across the x-axis. The x will stay the same, and only the y is going to change. Okay, so the next one over here, this one's going to be, this is your x-axis, this is your y-axis, but if you look at this line right here, up 1 over 1, up 1 over 1, up 1 over 1, this line is called the y equals 1x, and it's going through there, so it's going to be plus 0. So it's just the y equals x is what we call it. That's the most simplified form. Okay, so when it is reflected, it's a reflection across the y equals x line. When that happens, what we do is we exchange the x and the y. So here, if I start off with x comma y, what's going to happen is all of the x's will become the y's, and all of the y's will become the x's. They just kind of change places. Alright, the next one, last one, if you see this, this is like turning. So if you put your pencil down right here at the origin and you turn it 1/4 turn, that's a 90-degree turn, then you'll see what the next shape or the image would look like. So here, this is going to be a rotation, and it's about the origin. Okay, so here's the origin. And so it can turn this way, or we can turn it this way. Now, if we turn it to the left, that is counterclockwise. That is a 1/4 turn. So we call that a 90 degrees counterclockwise turn. Now, if you look this way, it's not going to be a 90 degree. If you turn it this way, that's in the 4th quadrant. So you would turn it again and turn it again. So it's got to make 3 turns. 3 times 90 is 270. So that would be 270 degrees, and that would be clockwise. Okay, so you're either going to turn counterclockwise or clockwise, and that's the rule. On this one, we're going to turn this direction, or we're going to turn this direction. So again, this is a rotation about the origin. Okay, and if I turn it to the right, I have to turn it. Notice how it's in the 1st quadrant. This is the 1st, 2nd, 3rd, and 4th. I want to turn it until it gets into the 3rd quadrant. So that's going to be 1/4 turn, 2/4 turns. 2 times 90 is 180. So the rule, that would mean that it's going to turn 180 degrees. And if you look this way, if you turn this way, it's going to turn once, twice, it's 180 degrees. So this one is 180 degrees clockwise or counterclockwise. Because they're the same, it doesn't matter. Doesn't matter which one you use. Okay, last one. It's still a rotation around the origin, so we call it rotation about the origin. Okay, so here I'm going to turn it this, if I turn it this direction, it's a quarter turn clockwise to move it from the first quadrant to the fourth quadrant. But if I want to turn it this direction, then it's going to be 1, 2, 3 to get it over here in the fourth quadrant. Okay, so this is going to be either a 90-degree clockwise turn, or it's going to be a 270-degree counterclockwise turn. Okay, so that's it for the notes in our review of transformations. In part 2, we are going to go over some examples, and there'll be a check for understanding section that you're going to have to do on your own.